Hi, my name is Kyle Mackey, Business Development Engineer for Navistar Next eMobility. Today we're here to talk about charging and what that looks like. Here at Navistar Next eMobility Solutions, we have a dedicated team to help with your site planning and engineering, creating complete EV charging kits for both AC and DC charger installations, EV charging equipment certification with our vehicles, as well as guaranteed uptime for EV infrastructure. Here at Navistar Next, we are here for all of your charging needs. Infrastructure is a key part to the charging process. The first thing we want to understand is how much power do we have coming into the building? How much is available for the charging itself? We also want to understand our short and long-term goals for our electric vehicles. What do our daily routes look like? What's the charging cycle going to look like? We can help with all that. If there are any infrastructure upgrades, please keep in mind it could take up to 6 to 12 months to get these completed. Once again, here at Navistar Next eMobility, we're here to help you with that process. The first step in the charging infrastructure process is to access the QR code. The QR code will take you to an online survey of 15 to 20 questions. Once the survey is completed, we will gather all your data and schedule an on-site assessment. Once all of our data is collected and reviewed, we will create a custom engineered plan tailored to your fleet and your site. Now let's talk about chargers. Today there are currently 3 different levels of chargers available. The one in front of us here is a level 1 bag charger. This charger will typically come in the back seat of your passenger electric vehicles today. This charger will plug into our vehicle, but unfortunately we do not recommend it because it will take a really long time to charge. The charger behind me is a level 2, 19.2 kilowatt AC charger. The charge port handle is a 1772 SAE standard connection. This is the same connection our vehicles are using. We chose this for several reasons. One, we understand our commercial customer is probably going to have other electric vehicles in their fleet. Also, if a driver is on his route and was able to grab lunch and plug in at a public charging station, this would allow him to do that. All of our recommended chargers will be network capable. This will allow us to send updates to the charger over the air, help diagnose charging issues, as well as allow the fleet manager to check in on their charging status. This is the recommended minimum charger for all overnight charging. Finally, we're going to talk about DC charging. On top of being more efficient and faster charging than AC, DC gives you a couple other options as well. For example, using the combo CCS1 adapter port that comes standard in our vehicles today, we can use vehicle-to-grid options as well as vehicle-to-building. This combo port allows AC communication and charging as well as the DC connection to give you both AC and DC charging options. As previously mentioned, all of our chargers are network capable. With that, we can initiate different charge times for a couple of reasons. This will help with the load on the grid, as well as get us down to that lower negotiated price for charging costs.
Hi, I'm Gary. We're in Rochester Hills, Michigan at Navistar's eMobility Next facility. In this facility, we do development for the medium-duty EV vehicles and the EV buses. Behind me is a test bench where we do all the development and testing for all the components that go into the vehicles. We wanted to give you an overview of some of the major components that make up our e-bus and our EMV. In front of us are the batteries, the main power support source for those vehicles. They are set up for groups of 3. One group of 3 we call a single string. That's good for 105 kilowatt hours of energy. 2 string is 210 kilowatt hours, and of course 3 string would be 315 kilowatt hours of energy. The bus will be available with a 1 string, 2 string, or 3 string situation, and the EMV will be available in a 2 string configuration at this time. The batteries are connected electrically in the supervisory box. In this case, the 3 strings come together in one location for the supervisory box. Supervisory box includes the contactors that also isolate the vehicle from the batteries when the vehicle's not in use. It includes the master service disconnects for when you want to work on the vehicle, and also includes the cell balancing communication, which ensures the life of the battery. In order to optimize energy and power from the battery over a long range of ambient temperatures, the battery thermal management system heats or cools coolant that goes through the battery. It does that through heat exchangers and chillers and pumps to be able to move the coolant in and out of the battery. The single source of putting energy back in the vehicle is from the charge port. Whether you're doing AC charging or DC charging, the charge port is where you put the charge gun. In this case, we're going to insert the charge gun into the level 2 connection. and you'll be able to hear the vehicle in the background going through its paces in order to successfully charge the vehicle. Once the vehicle is successfully charging on level 2, you'll see the draw in of the wire, and you'll see the green light blinking to indicate safe charging. One of Navistar's strengths is in the Vehicle Control Unit, or VCU. The VCU houses all of the software that brings all these electronic controllers together, makes the vehicle move, it makes it stop, it makes it go, it allows it to charge or discharge or regenerative braking. All that integration, all of that software is contained in the Vehicle Control Unit. To show you the drive system, we've moved underneath the bus. The motor is 335 horsepower. It's the same motor that drives both the EMV and the electric bus. The motor is driven by an inverter, which converts DC energy from the battery to AC energy to propel the motor. Further, the motor drives into a drive shaft, which then goes directly into the differential, which then drives the wheels. We gave you a great overview of the components and systems that make up our EMV and electric bus systems and vehicles. If you'd like a tour, please contact your IC bus representative or your international representative for more information.